Okay. So, all right. So we were explaining this in terms of the quantum complementarity effect. So that means the wave nature and the particle nature when they express each other. So let's say wave nature is expressed through the momentum or the wave vector. Wave vector is related by de Broglie's relation to the momentum, right? So if you know the momentum precisely, or you know the wavelength wave vector, so you know the wave properties. So that is one variable. Another conjugate variable to that is your position, right? Position and momentum are conjugate to each other. So you cannot measure both with 100% accuracy, right? So there has to be some uncertainty and this conjugate variables. So if you remember the principle of uncertainty, so you can measure only one of them with perfect certainty, right? So here you see, you are the moment you are putting the polarizer, you are sort of making it like a particle. So that means you are confining it in space. So that means you are knowing its position exactly. You are knowing the path. So you are knowing its position. And when we did not have this, so the path was fuzzy, but we had a perfect wavelength because that's the wavelength of the laser. So the wavelength was known properly. So that means the momentum was sort of known properly, but the path was fuzzy. So it was behaving like a wave and it was getting given as interference fringes. Now quantum eraser says that if we somehow eliminate this information of the path, or erase this information of the path, and then you can again get back to that wave nature of this object, whatever it is, and then we can restore the interference fringes. Now you see, if I place this third polarizer here, I hope you can see. Now I have placed a third polarizer here, as you can see here. Okay. Now if you zoom in to the screen, you see we have got back the fringes that were there before. Okay. So why is that so? What extra thing this polarizer does? So now this polarizer is having an angle that is in between these two. Okay. So it's like at an angle of 45 degree with the polarizer 1 as well as the polarizer 2. Both this, the polarizer 3 is at 45 degree with both these polarizers. So that means it's for this current experiment it is at 65. You can set up other numbers as well. It's not necessarily has to be this. So it is 45 degree with both of them. So that means now that because it is 45 degree, so now if I observe one photon reaching the screen, the act of making it 45 degree is that whatever light was polarized around 20 degree, let's say, and for example this one 20 degree, this one is 110 degree. So now both of them after passing through this are polarized along the direction of this one, right, 65 degrees. So now just by looking at the polarization state of the photon that is reaching there, I cannot tell which path it is coming from, right? So both of them are now polarized at this angle 65 degree, which is 45 degree to both of these first two polarizers, right? So that way I can no longer tell the path. So that means the particle nature, the information related to the particle nature is gone, it has been erased. So the wave nature has been restored again because it was coming from this laser, so it has a perfect wavelength, so it is like a wave. So the wave nature is restored back, and that's why we are observing the fringe pattern again. So this is quantum eraser. This experiment is the erasure of quantum information. So that polarizer serves the purpose of the eraser there. Okay. Same thing you can do with this screen as well. Now if I look at this screen, there is no fringe pattern there. But if I bring, let's say, the third polarizer again on its path, the fringe pattern here also will be restored. So if you can see, so if you look at that, now there is a fringe pattern there. Okay. So that's the quantum explanation of the phenomenon here. In the same way, you can, but ultimately this experiment is a classical experiment, so you can have a classical explanation as well, because the third polarizer, so the waves that were reaching there were polarized normally to each other, so they were not producing any interference fringes. But because the third polarizer polarizes both of them about a 45 degree to the original states of polarization, so now they have this, whatever photon after passing the third polarizer reaches the screen, all of them are polarized along one line. So now they can create interference pattern. So that is the classical explanation. Okay, so the quantum explanation is in terms of the erasure of the information of the path. Okay, thank you for listening.